Okay, so today I'm going to be speaking. I've still got a bit of a ring going there. I think there's still a bit of a feedback. Yeah, it's a little down. So today we're going to be speaking about Groovy and Scala, friends or foes. Right, so I think many flame wars have been fought around silly things like this. So going with an open mind, I just want to raise a little philosophical issue almost. Why do people fight about things? Why is there disunity? It seems to be a part of the human condition. Humans always tend to group together, form packs or tribes around something that they like, and then the next step is they identify another group that believes something differently. They end up erecting walls, separations, and they start throwing stones over the walls, and you get a very uncomfortable situation. But at the end of the day, it's all just based around likes and dislikes. One group of people might like one thing, another group of people might like another thing. It's all just a very subjective thing that brings people together in this way. And this happens around all sorts of silly things. It happens around politics, sports, even stupid things like gender or race. It just drives walls between people. So there's a great quote from the Dalai Lama. The planet does not need more successful people, but the planet desperately needs more peacemakers, healers, restorers, storytellers, and lovers of all kinds. And that's another quote from a great book, Blessed are the peacemakers, for they shall inherit the earth. So this talk is about building bridges, about looking at what's on the other side, and how we can potentially embrace it and actually use it side by side with our ecosystem. Right, so enough of that. Just at a very high level what this talk is about, we're going to be looking just at a very high level at what type systems are. We're going to look at how that pertains to dynamic languages and statically typed languages. Then we're going to look at Groovy and Scala and how they basically fit roughly into these categories. Then I'm probably not going to go too deep into the Scala features because that would take too much time and we're quite limited on time. So I'm going to go straight into the demo from there. We're actually going to test drive a little application using Gradle and Spock, test driving a little piece of Scala implementation code, and hopefully you'll see some of the nice Scala features there coming out and see how the interoperability works, which is a lot of fun. Right, quick word about myself. My name is Marco Vermeulen. I'm a software developer. I love working with Groovy and Scala and Java, all things Java or JVM related actually, and I enjoy other languages too. So I'm working as a consultant at the moment for a company called Equal Experts, and I'm currently working on the HMRC project. So for those of you who don't know what HMRC is, that's basically the British Tax Office, and we're busy rebuilding the entire web platform with modern new technologies. We're using Scala, Play, we're building everything with microservices, deploying with Docker to a platform, so it's really leading edge stuff and a lot of fun. And then in my spare time, I'm involved with the Groovy community. I'm the creator of GVM, which I still actively support, and I blog at Wired for Code sometimes, and on Twitter I'm called Marcoda with a 0. Right, so enough about that. Type systems. So in order for us to know what a type system is, let's look at a definition by Barbara Liskov. In the early 70s, she defined a strongly typed language as the following. Whenever an object is passed from a calling function to a called function, its type must be compatible with the type declared in the called function. So in other words, if I'm a caller and I'm calling to a callee, if there's such a thing, and I'm passing an object, there needs to be a level of compatibility between what I'm sending to what is being expected on that side. So a strongly typed language will be quite pedantic about that level of compatibility. So I'm going to describe two continuums that are involved here. First one is strong and weak typing. Now, what is strong and weak typing? So if a language is strongly typed, it really enforces that type compatibility to what we're calling, to the method that we're calling. It'll really go to town on that validation. Whereas weaker type language is something which is more permissible. It will allow other things to go through. It will relax those constraints. Then you have the continuum of dynamic and static type languages. So this is interesting. A statically typed language does all that type checking really early on in the compilation phase. Whereas a dynamically typed language, even though it can be compiled as well, like Groovy is, it will actually do the type checking at runtime. So those are the two kind of things that we always need to consider when we're speaking of type systems in languages. Right, so just a very quick example, statically typed languages there, Java and Scala, you see they explicitly there mention what the type is, and it simply won't compile if those are out of sync with what's being assigned there. Dynamic languages, for instance, there's Python and JavaScript. In the Python example there, you'll see message is first assigned as 1, 2, 3, 4, 5, and then it gets reassigned over there as message, which is as a string literal, which is a completely different type, but Python doesn't complain. Right, so I've got to put in some anime. Dynamic languages. So definition of dynamic language on Wikipedia is a dynamic programming language is a term used in computer science to describe a class of high-level programming languages which, at runtime, execute many common programming behaviors. That static programming languages are formed during compilation. So that's basically what I just described. That behavior we're talking about, type checking, happens at runtime. Right, so let's look at some pros and cons of dynamic languages. So firstly, dynamic languages are often a lot more concise. They're a lot less verbose than what statically typed languages are. There's no upfront compilation, well, some types. Some dynamic languages do have upfront compilation, but a language like JavaScript, for instance, doesn't. Faster turnaround time. You get faster feedback because you don't depend on that compilation phase up front. Monkey patching. So this is a fun part. This is where you can actually change the behavior of an object at runtime. So this is, for me, this is the really cool stuff, you know, where dynamic languages really shine. Another thing is, for instance, duck typing, where we can actually pass an object into a method taking advantage of that weak typing. There's a saying that says, if it walks like a duck and it quacks like a duck, then it's a duck. But that doesn't necessarily mean that it's a duck. You could be passing in something else that's posing as a duck to do really cool stuff. So there'll be a little example of that later in the code as well that I'm going to be demoing. Strong focus on TDD. So those who know me know that I love test driving everything. I like going to town on tests. And for me, that becomes really valuable in a dynamic language. So I think if you don't have strict type checking, then you need to rely on something else to make sure that your code is sound and that it's all working, so that you don't have surprises by the time you go and deploy it. And I think most of all, dynamic languages normally attract pragmatic people, people that think out of the box, people that are willing to try new ideas. So it inspires pragmatism. On the downside, if you don't test drive your code, you're going to get surprises. And I think we've all seen that. You know, if you're not strict on that, then things happen. We've all seen it. They are potentially less performant because now it's doing a lot more work at runtime that normally would have happened at compile time. It makes refactoring a little bit more difficult. So obviously your IDE has to work a lot harder in type inference, whereas before it could have just used the static type system to determine what methods are available, what can and can't be done. So you lose out a little bit on the ability to refactor in your IDE. Right, statically typed languages, on the other hand, some pros there. You have earlier detection of type errors because it's now happening at the compilation phase. So this one, so self-documenting code. So if you have explicitly declared types, it describes your code better. Some argue that as a pro of statically typed languages. Compiler optimizations. So before your code goes into a runtime state, you have a lot of work happening in the compiler. So compiler optimizations can help you with great gains at runtime, improved runtime efficiency, and improved IDE support, like I already mentioned earlier. So, on the downside, sometimes statically typed languages like Java are a lot more verbose. You have a slower development process because now you have to wait for compilation to finish every time. It dilutes test-driven development. So, I've noticed this in practice where people who depend very strongly on the type system don't see the need to actually do unit testing. So I think they kind of missed the point there, because the reason why we unit test isn't always just to see that your code is sound, but also to help you drive out your design. I use TDD so that I can express my intent and then write the code and see it evolve naturally. So now, how does this fit into the world of Scala and Groovy? So, first of all, I think, for me personally, Groovy is like the Swiss Army knife, right? It's just an absolute, it does so many things and it does it so well. It's a very diverse language. So, firstly, it runs on the JVM. That's always a huge bonus for me, because that allows me to run it almost anywhere. It's object-oriented. It is more imperative in nature, even though it does have functional aspects to it. It seems to be closer to Java in that respect, that it's very much an object-oriented, imperative language. It's basically a really nice sugared-up version of Java, effectively. It just helps people who work with Java to get going a lot faster. It's optionally typed, so you can make your strength of your typing as strong as you want in Groovy. You can declare all your types and have very strong type checking, or you can relax it completely and make everything a def. That's your decision to make. It's very well suited as a scripting language. It's got most awesome Java interoperability. So this is one of my favorite features. You can just pull in just about any library, any jar, and you can immediately start using it. And you've got all the benefits that you can extend a Java interface in Groovy or vice versa. So that all just works seamlessly. Right, and of course, it's compiled, not interpreted. So it does actually have a compilation phase. But it allows you to do really cool stuff at runtime with metaprogramming. And of course, now it can compile statically as well. So we've got the best of both worlds. And another thing, one of my favorite things about Groovy is the Groovy console. You can write nice little snippets of code, just slap it into the Groovy console, run it, and immediately get feedback. That's just such a big bonus. And like I said before, I think it's the Swiss Army knife of JVM languages. Right, Scala's got a different nature. If I look at Scala, I think of a precision tool. It's got a totally different application to what Groovy potentially has. So first off, once again, it runs on the JVM. It is functional first. So even though it does have object orientation at its core as well, it can almost be described as an object functional language. It teaches you to think more in functional programming concepts. It is a very strongly and static type system, yet it does behave like a dynamic language. You'll see later, we can do all sorts of things which make it seem like you're in a dynamic language. The syntax, for instance, is extremely terse. So it's not as verbose as Java. It relies quite heavily, or you can rely quite heavily on type inference. So you don't have to declare all your types. A lot of that actually gets inferred along the way, which leads to far more terse code base. It's definitely compiled. And like we have the console, and we also, I think we still have a record as well, Ruby SH, yeah. So the Scala community rely quite heavily on the REPL, which is also a really, really good tool for just writing little snippets of code, testing it out. It's got nice tag completion, so it's very, very useful. And it has many cool language features. Too many to mention here, but it is a really rich language. Right, some drawbacks. So the compilation phase can be slow. It's not always slow, but it slows down when you start having a lot of type inference and implicits. So we'll talk about implicits a little bit more. Those are the things that make Scala seem like a dynamic language. They're actually a really cool feature, but if you overdo it, it's just going to grind your compiler to a halt. So this is one thing I've also noticed in practice, because there is such a focus on writing very dense, terse code. People spend hours and hours scrutinizing over a little bit of code. Whereas with Groovy, it's more pragmatic. It's like, let's get going, let's get something out there, let's get something working. Whereas it's almost like a bit more of a philosophical art programming in Scala, because you check it out, I can do that a little bit better. So then you revisit it, then you rework it, and then when you pair programming, it gets even worse, because you're constantly talking about these things, about a nicer way of doing things. Then you've got pretty nice code, but it takes a bit longer. Okay, so this is one of my grievances, is at the moment IntelliJ support for Scala is not up to scratch. If I compare it to the support that we have for Groovy, which is seamless, it just works, I cannot always say the same about the Scala plugin for IntelliJ. So I really do hope that they address this in time going forward. So, highly functional code can be difficult to unit test. So, your level of unit testing is probably going to change. You're going to be a little bit more in an objective mindset, describing behavior. And it's also, with unit testing, it's quite difficult now to mock things out, because with functional code, mocking isn't always that simple. So that's something that I found, that unit testing is a bit harder. And of course, debugging is difficult, even in Groovy. If you start becoming more functional in Groovy, your IDE is not always going to play very well when you put in breakpoints. So, and that's another one. So, I'm a big Gradle fan, and I would much rather use Gradle everywhere where I can. That's just another place where Groovy shines for me, is Gradle has just come to save the world when it comes to build systems. And SPT is a really horrible, clunky thing to work with. I really struggle with it day in, day out. Okay, so at this point, I think I'm going to move across and we're going to skip this section where I describe the features and we're going to go straight into the demo. Right, so the little demo, sorry, that's not very well stated there, but has everybody heard of the FizzBuzz coding kata? You want to just see a show of hands? Quite a lot of people, about half of you. Okay, so just for the sake of those who haven't heard of it, it's basically a little piece of code. You pass in a range of numbers from, say, 1 to 20 in this case, and it's going to parse out, or it's going to render a string that is going to contain all those numbers padded by spaces. Right, and then that's the first step. Then the second step is you're going to add functionality that it's going to replace all the numbers that are multiples of 3 with the word fizz. Then the next step, you want all multiples of 5 to be replaced with buzz, and you want buzz to take precedence over fizz. And then the last step is multiples of 15, same thing again, this time it's fizz buzz, and fizz buzz takes precedence over buzz and fizz. Right, so that over there is basically what you'll output. Okay, so let's get cracking. Right, is that all right? Everybody see that? Good. Okay, so I've already cheated a little bit. I've got like the first test in position. So this is a Spock test. Before we do that, I'm just going to show you our Gradle build file. So I love using Gradle for everything, like I said, and it just works so beautifully with Scala as well, and especially when you're using Groovy and Scala in one project, it works fantastic. All you need to do is you need to add that line over there, apply plugin Scala, and then of course you need to just add that compile dependency on the Scala library that you want to use. In our case, we're using the latest 2.11.6. And then, of course, I just have Spock in there as well with Groovy as a test compile dependency, and it just works. You can import it straight into IntelliJ, and immediately everything works. Right, so there we go. That's our test. Should render contiguous numbers. So that's the first step in what we described earlier. Right, so given a range from 1 to 20, so that's a Groovy range, and I call this FizzBuzz class, static method process, passing in the range, then I should get back a result that looks like that comment. And then I've got an ugly little line there that takes the result, tokenizes it, and gets from the given position the word that we have, and I assert that the word matches up, and that's the data-driven test over there. So just in quick preparation, there's two little things we need to do first. Let's extract this horrible little thing into its own little method. So I'm just going to call that expecting. That's going to take a result. a word and a position. There. So that takes the result, word, position. Let's type those. String. And it's just going to be int. Put that in there. There we go. Good. So that's fine. Let's step into our fizzbuzz artifact. So fizzbuzz.scala. It's just a plain file we have there at the moment. So we'll start off by just adding a package. And we can add a new construct in here. It's not going to be a class. So you noticed it was a static method that we were calling on fizzbuzz. Now Scala has this notion of an object. So an object is basically like a static class. So we can call that fizzbuzz. There we go. And everything that's inside those curly braces are basically static. It's almost like object is actually a singleton. So that's how you refer to it in Scala language. An object is basically a singleton object. So immediately we step into here, and you immediately see it starts compiling and picks up fizzbuzz. So now we're going to add a process method. So that's diff process, and it is going to take a list of type int, and we are going to return a string. That's what a method signature looks like. And interestingly enough, I put in 3 question marks, and those question marks are effectively going to cause the code to compile, but if we invoke this, it's going to throw a not implemented error. So this is a really nice way to get your code compiling and to get your test failing. So there we go, you see the code. That's what you want. You want to start with a failing test, and then you want to start implementing, get it green, and then you do your refactor. So compilation is the first thing here. Now if I run this, we're going to start seeing an interesting thing happening. So remember, we're passing a range into this method, but that's a Groovy range, it's not a list. So let's just kick the tires first to see whether this is all working and it's actually picking up the class. And there we go. Missing method, no signature of method, fizzbuzz process is applicable for argument, Groovy language. So we need to do a little conversion here. Now one thing about Scala is that it has its own collections API. It's not like Groovy where we use hash maps and array lists and so forth. Scala actually redefines all of these in its own way, and it adds a bunch of functional stuff on top of their collections. Their collections were quite different to Java. So how can we remedy this? Fortunately, they do provide us with a special helper API to help you do type conversions. So there's Java conversions, and then there's an as Scala iterator. So what we can do here is we can actually take our range, we can feed it in, get out the iterator, and to list, which is going to return a Scala list. So if we run this now, we should start seeing a slightly different picture. Right, so there we have a not implemented error. Good, so that means it's actually, we now have Groovy speaking to Scala successfully. Wonderful, so once again, I'm just going to refactor that and just quickly extract as Scala list. Now here I'm going to use a little trick, what I mentioned earlier, duck typing. So I'm going to create a helper method. And as Scala list. And I'm not going to type this at all. I'm just literally going to pass in a collection of sorts. Over here, I will now just literally do collection.iterator, which means you can pass any collection that has an iterator in there, and automatically it will just pull out the iterator and convert it into a Scala list. Great, so let's run that again. You should still see our not implemented error if all is well. Excellent, that worked. So notice how quick it all compiles as well. People always have this idea that Scala takes very long to compile. So IntelliJ have done something really nice. They've got a little, like a little compiler called Nail Gunner. You see at the bottom here, there's like a little dash with a little dial in there. So that little dial over there is basically just saying that Scala is just compiling in the background, and as you're typing, it fires off tiny little compilations on that file, and it happens transparently while you're working. Pretty neat. Okay, so what we want to do now is we just want to get the test to pass. So I should have just copied the other one. Good. Let's run that. So this is the simplest thing possible to get the test green. And it's green. Right. Now that's not a very elegant solution, and it's not going to scale very well because if we change our range, it's just immediately going to break. So let's start off by using a method on the Scala list that can help us. So very much like the join function that we have in Groovy, we have a make string that takes in a parameter which is just going to be the delimiter that sits in between. So if we run that, that should now pass. Ooh. Right, so let's start describing the rest of our behavior. So we're on to our second step now. So let's say should render fizz on multiples of 3. Right, so I'm going to cheat a little bit, and I'm just going to steal that little bit up there. Put that in. So just a question, can I just see a show of hands who uses Spock on a day-to-day basis? Most people, very good. So has everybody used a data-driven test using expect and where? Most people, yes? Yeah. So you're all familiar with how this works in Spock. Good. So our expectation here is, sorry about those, is fizz, and that's going to happen at position 3, 6, 9, 12, 15, and 18. And we can remove them over here because we know that they shouldn't be in here anymore. 3, 6, 9, 12, 15, 18. Right, so let's run that and watch it fail. Ooh. Okay, so we're expecting the word fizz, but we're not getting it. So, let's use some functional programming here. We're going to use the map function on the Scala list. So the map function takes in another function. And that function is basically going to operate on every single element in the list. So now we've got a list of ints here. So immediately we can use Scala's type inference. When we use I over here, it immediately knows that it's going to be an int. It's going to pump in an int into that. So we're going to say take the I and do a quick check. So we can say if I modulo 3 equals 0, so that's going to tell us whether it's a multiple of 3 or not. Then just return this. Else, we're just going to go I dot to string. Right, so that should work. That should give us what we want. It's not very pretty, but it'll work. And we're green again. Now, we can probably make that a little bit more elegant. So while we're green, let's go in and let's extract another little function. And we're going to just call this thing replace. Right, so we'll make that a private def place. And this is going to take in an int. And it's going to return a string. So this is going to operate then on every single element. Let's run that again. Cool, and we green again. So notice that I'm just passing in this function as an object into that map. And Scala knows to match that function, which can only take an int and return a string, and be able to apply it to every single int that's being passed in. Notice we are constantly speaking about the types here. You constantly have to be aware of the types you're working with. So your brain sometimes has to work a bit harder when you're working with Scala than when you're working with Groovy, where Groovy seamlessly just does all the type conversions for you and just adds all the sugar for you to do all that work behind the scenes. So yes, it does. Okay. Right, so there we go. It's green. Next step. Let's do the test for buzz. So we're going to say should render buzz for multiples of 5. Good. So stuck that in there again. And this time, it's going to be buzz, and we're going to have it at position 5, 10, 15, and 20, which means we can now remove it from there, and we should be able to remove multiples of 5 from here as well. 10, 15, and 20. Right, so now we're failing because the buzz is not there. Okay, so here we have something that's not very extensible. We've got a function here that is only going to check for multiples of 3, which is not really going to help us. Notice that I've put everything on one line. Okay, I've got curly braces missing. There's no curly braces. I can put everything on one concise line, and it actually reads quite nicely. So let's replace this with another thing, a really nice feature that we have, which is called pattern matching. So pattern matching allows us to say, match I to one of these cases. The first case being x if x modulo 3 equals 0, then do the following, return first. And if it's going to be a 5, buzz. Okay, so let's run that up and see what that does. You see how nice that reads? That's really comfortable on the eye. We're going to improve it a bit more in a second. Oh, something's broken. Sorry? Yeah, of course. Thank you. This is bad programming, right? And we're going to just say x dot do string once more. Cool. One final case we want to cover is we want to do fizzbuzz. Almost there. should render this buzz for multiples of 15. Once again, cheat. And this buzz, and that's going to be only at position 15. And we can leave that work today. Run that up. Cool. So obviously this is very easy now. We can literally put 15 in there, this buzz, and we're all passing. Yes, good. Right, so now the last little thing I want to show you, we're almost done. We have to show at least one little advanced feature. So I'm going to show you an implicit class. Now, an implicit class is what mimics that dynamic behavior I was speaking about earlier. It makes you feel that you're in a dynamic language. So wouldn't it be cool if instead of the ugly if statement there, we could do something like x if x is multiple of 15. Right? That would be really nice. That's what you'd expect in a dynamic language. You'd be able to add a new method. So, in steps the implicit class. So, we can declare an implicit class. We're just going to call it anything enhanced int, which wraps an int. And we define the method we want. So, is multiple of int, and it's going to return an int. Boolean, sorry. And inside there, we're going to say, I'm just going to say, sorry, it should be J. We say I modulo J equals 0. And immediately you see the ID picks that up, puts a little grey line underneath. We can now basically go and refactor all of these to use that new method. X, IntelliJ immediately picks it up there as an option. 5. And X is multiple of 3. Cool, let's run that. And we're all green. And there you go. Seamless interoperability between Groovy and Scala. Thank you very much. Right, do you have any questions? Is there time for questions? Okay. Any questions regarding this? No, nothing? Yes, this one.
So Scala is a focus tool. What do you recommend using Scala? Is it a Groovy?
So for me, it all depends. If I want to do some really precision, performant work, kind of like working on a trading system or something like that, implementation code I would see as a candidate there for Scala. As opposed to Groovy, I would then maybe start using more for all the glue code around your deployment and your build process and things like testing. Groovy works beautifully with Cucumber as well, for instance. You know, those are the areas where I would personally then use Groovy. Although I still use Groovy in production code as well. So for me, it's a toss-up. Any other questions?
Well, just a little bit remark. It's a nice thing to see this is perhaps if you switch back to the spec, where the code is explicitly made how you transform from any list to a Scala list. Perhaps we can use the same trick as the Scala places to use Groovy model extension, so that compile time you automatically get that conversion and you don't have to apply it every single time.
Very good point.
But it will take more time to really set up for conservation.
Yeah, absolutely, very right. So, did everybody hear that question? Yeah? Okay. So yes, you're right. That's a definite candidate. But yes, because we don't have enough time, I'll just quickly act it and put it out of the way. Good. Any more questions? No. Okay. Thank you very much.